Hello students, welcome to the Thrust of Curiosity. Today we are going to learn about a type of material called as semiconductor. There are other two types of material also which you know as insulators and conductors. So what are the difference between these types of material? So basically you heard the difference according to its resistivity or conductivity. It is said that the conductivity of semiconductors is in between the insulator or conductors, or resistivity is in between the insulators and conductors. Now this is not complete definition. There are different aspects of this definition or the definition of semiconductors. This is because the conductivity of semiconductor is not a constant value. It can change. It can change because of the different aspect which we can say as temperature and doping. Okay, so I will let you know what is doping, but this means that we can control the conductivity of semiconductor. It is not just like that, okay, it has a fixed value of conductivity and we cannot change that. It is always in between insulators and conductors. It is not like that. We can alter or we can change the conductivity of the semiconductors, which depends on the band gap of the material. So I will shortly explain what is band gap. You might have heard there are different energy levels in the structure of atom or molecule. So the lowest field energy level is called as a valence level, and if the material in the material there are so many molecules, then each molecule have different energy state and which becomes one band. Okay, so I will try to plot here. Suppose this is a valence shell and this is a valence band. Okay, so this in this region there are the electrons. Okay, so this all thing, this with this width there is a valence band. Okay, I will name this as valence band. So at 0 Kelvin, by definition, at 0 Kelvin, this valence band is filled partially or completely. This is the highest energy level which is filled at 0 Kelvin. This is important, at 0 Kelvin. So this is completely or sometimes partially filled at this temperature, and there can be other level above that because there will be some excited states. So this is band, and at the same temperature this band is the lowest energy band which is completely empty. Okay, so there can be all bands which are empty above this energy level, and there may be so many bands below the valence band which are filled. But we are seeing that by definition valence band is the highest energy band which is filled at this temperature, and this conduction band is the lowest empty band. Okay, so the energy difference between these two, there is a gap. So the in between these two levels, or two bands, there are no electrons present here. So this is called as a band gap. Okay, the highest level of valence band and the lowest level of conduction band, the difference between these two is called as a band gap. Now for conductors there is no such thing as a band gap, because in the conductor the valence band and conduction band are overlapped on each other. So why we need conduction band here? To see the concept as when the electron gets enough energy and it jumps from conduction band to valence band to conduction band, then it is available for the electrical current. So this electron can come to conduction band and it can pass from one atom to other atom, and it can further proceed, it can further travel. So this is available for the electric current. In conductors, in valence band itself, they are available for the conduction. So therefore, there is no concept of valence band and conduction band in the conductors. They are, we say that they are overlapped. Now, in semiconductor, this band gap is in the range of 1 point up to 1.2 electron volt. Okay, so from conductors, like from 0 electron volt to 1.2, this figure may vary. If you search on Google, this can vary a little bit, but this is the, or 1.4 electron volt, sometimes you can see 1.1 electron volt, and so on. So in within this range, if the material has the band gap in between this 0 to 1.2, or any band gap within this limit, less than 1.2 electron volt, then the material is said to be a semiconductor. Now here we don't need to say at particular temperature, because band gap is calculated only at 0 Kelvin. So temperature is fixed. Now what happens about the insulators? So in insulator, this band gap is so large that the electrons will not jump from this level, valence band to conduction band. They cannot jump with our regular electric supply or light when it falls on the valence band. So the band gap of insulators is above 1.2 electron volt. It can have the band gap up to 3.3, or some have 3.4, and so on. They can have these values. But sometimes you can see some materials you use which have the band gap more than 1.2, or sometimes more than 1.5 electron volts, and still we can call them as a semiconductor. This is because we can control the conductivity again. So this is also not a complete definition, but most of the time we can use this definition. So now we will see what are the types of semiconductors. So there are two main types, which is intrinsic and extrinsic. Now in intrinsic semiconductors, we have, for example, okay, let's have a look on the periodic table. Okay, you can see in this periodic table, these you can see the colored elements are metalloids or semiconductors. They can be used as a semiconductor. So mostly we know the silicon is the famous semiconductor, and germanium is also very famous conductor, semiconductor. So why they are called as a semiconductor, and what is the properties of this conductors? This is carbon group, this is called as. So in this group there are 4 electrons are in the outermost orbit. So if you have studied a little bit of chemistry, you know here are only 1 electrons in the outermost orbit, and here there are 7 electrons in the outermost orbit. So what happens? This wants to lose the electrons, and this material want to accept the electron, but here there are 4 electrons. Okay, so they can either donate or accept 4 electrons to fulfill their octet, but sometimes it is not possible. So they have the covalent band. Instead of ionic band, they have covalent band. So number of atoms come together and share their electrons. So both atoms can use the electrons. So suppose this is outermost orbit of silicon. So here is 1 electron, here is 1 electron, here is 1 electron, and here is 1 other electron. So these are 4 electrons in the outermost orbit. Now surrounding there will be all 4 atoms. So this will also share 1 electron. Okay, so these are 2 electrons. here also there will be other atom of silicon, so they will also share one electron. So they have four electrons. Each atoms will have four electrons in their outermost orbit. So these four electrons are there. Don't mind my drawing. So here will be also one more electron, here also one electron. So this type of bonds are called as a covalent band. So all this type of mostly silicon and germanium we are talking about, these share such electrons and form a covalent bond. So both atoms have full field. I mean, here also this atom also does the same, this atom does the same, all atoms does the same, and they try to complete their octets. So such type of semiconductors are called as intrinsic semiconductors because they have complete their octet. Okay, the electrons available in this type of material, intrinsic semiconductors, is because they can absorb the energy and go to the conduction band, and then they will get available to transfer or to pass as an electric current. On the other side, there are in extrinsic type of semiconductors which we create by doping one atom or molecule inside the other bunch of atoms. So you can see here, this is 14th group, carbon group is 14th group, and if you see this boron, aluminum, gallium, they are 13th group. So there are only 3 electrons in their outermost orbit. And this is nitrogen family. In this we have 5 electrons, nitrogen, phosphorus, arsenic. They have 5 electrons in their outermost orbit. So what happens when instead of this silicon we dope some other material? Doping means to inserting the other element in the structure. So I will draw with a different color, let's say this. So I have added, suppose, nitrogen or which one, phosphorus, okay, which has 5 electrons in the outermost orbit. So what will happen, this atom will share its one electron here, but there is one more electron which is not forming any bond and which is available for the transport. So that is the current, or therefore the conductivity is increased because of this doping. Sometimes what happens, the trivalent impurity, so this is called as pentavalent impurity. Pentavalent means the valency is 5, or the number of electrons in the outermost orbit of that particular element is 5. And trivalent impurity means in which there are only 3 atoms. So instead of this, so there will be no electron here, so this bond is empty here. Now you can see, though there are different number of electrons there, the whole atom or the whole system is electrically neutral, because the number of protons inside the atom will be the exactly same as the number of electrons here. But this is possible that we can have availability of charge carriers. We call them as charge carriers. Okay, so these can be electrons or absence of electrons, which we call as hole. So this is one hole. So because here is one absent electron is absent here, because this is trivalent impurity. Okay, only 3 electrons are in the outermost shell of this. So this is not possible for this atom to share one electron here. This is already sharing 3 electrons with some other silicon atoms. There are also silicon atoms. Okay, so this doping is nothing but adding one impurity, either it is trivalent or pentavalent. So this trivalent impurity, when when we add trivalent impurity inside the intrinsic semiconductor, we get p type of semiconductor. And when we add pentavalent impurity, or the impurity with 5 electrons in the outermost orbit, we get the n type of semiconductor. Why n type and p type are the names? Electrons, if electron rich element we added, so this is giving us the negative charge, so n stands for negative. And when holes are more, that means electrons are less, so this means we have some kind of positive charge, so therefore we call it as a p. So if we have n type of semiconductor, this means we have added the pentavalent impurity. Okay, I will write these two words also, pentavalent. So when pentavalent impurity is added, we get n type of material. And when we add trivalent material, where the valence is 3, means the number of electrons in the outermost orbit is 3. So if trivalent impurity is there, this means the number of holes are more or number of electrons are less. So if the pentavalent impurity we add, this becomes n type of semiconductor. So these are called as extrinsic semiconductors, both n and p. Okay, and these are charge carriers. Electron is a charge carrier and holes are charge carriers. So what is the role of these intrinsic semiconductors? Why we use them is because you can see just by doping, this doping is very less. I mean, if there are 1000 atoms, we just add one impurity, and this changes the conductivity so rapidly, right? So therefore, by doping, we can change the concentration and we can change the conductivity of the material, because we have free charge carriers. We have added free charge carrier, either they are electrons or they are holes, depending on which element you are adding. This base atom mostly is silicon or germanium, and in that you dope trivalent or pentavalent impurities. Okay, so 13 group, this group boron family are trivalent, and nitrogen family are pentavalent, and carbon family is tetravalent, means they have 4 electrons in the outermost orbit. So by adding small amount of this trivalent or pentavalent impurities, we can alter the conductivity. So all the electronics is revolved because of these semiconductors. After the discovery of semiconductors, the electronics has grown very rapidly, like exponential growth it has made, and the size of components you see is decreasing, still it is decreasing. So this is very helpful, and we will see some devices made with the help of semiconductors in some next lectures. Thank you.